today's lesson is over exponential growth functions, okay? This formula is not found on your star chart, so you will have to memorize this one. It is actually pretty easy to memorize. Once we do it enough, you'll absolutely remember it. So what I want you to write down is the equation, which is y equals a, open parentheses, b, close parentheses, to the x power. So today we're talking about exponential growth. This means it is not linear. What is linear? It's not straight. This is not a straight line. This is like when something grows so rapidly, it just starts to curve real quick. Okay? It does have like a rate that it's growing at, but it's growing by multiples. So that's why you have that exponent. So we're going to talk about the pieces of this formula. The first thing you need to know is this number right here is your starting amount. That is your starting amount. The number in parentheses is the growth factor. The growth factor is found with the percent. So it's growing at a percent rate. The way that you do this to find the growth factor, it's basically like taking 100% plus the percent you're growing by and then changing it to a decimal. So 100% as a decimal is 1. And then you, oops, I meant to put 1. And then you add it to the percent it's growing by, but you change it to decimal form. And this will all make sense in a minute. And then the exponent is always going to be a variable. That's always going to be your x. Okay? Like, so you're not filling in the number for that. All right, your calculator will write these equations for you using stat. So right here at the top, I want you to put the options. So you're going to go to stat. You'll go to edit just like we always do, and in edit you'll put in your tables. So y'all already know how to do this. So in L1 you put your x's, and in L2 you put your y's like we always do. But when you go to choose your options, you go back to Stat Calc, and you're not going to choose the option for linear. You're going to choose the option for exponential, which is option 0. So after Calc, you're going to choose option 0 for exponential. And it will write the equation for you. So you won't have to write it if they give you a table. Okay, there is a vocabulary word I want you to be aware of. It's called an asymptote. An asymptote is a line that your graph will approach but never touch. So we're going to write that down. It is a line. Can y'all see that? Yeah. This, you can see that color? Okay. A line that your graph will approach but never touch. And I'll show you before we move on. Okay, so I want y'all to, first of all, go to your Windows. And we need to like really zoom out because we want to see what we're doing. So go to the X minimum and go put it, window, go to X minimum and change it to -10. Change the X maximum to +10. and do the same thing for the y minimum and y maximum. So negative 10 and 10. That way we're zooming back into our graph to see more. Yes? Okay, now go to y equals. If you have anything in there, just clear it out. And I'm going to make up a exponential equation. So let's put in 2 open parentheses, 1.02, close parentheses, and then to the x power. So make sure you go to that exponent for the x. Hit graph, and this is what a exponential function looks like. Why does it look like that? Did I do something wrong? Let me try a different one. There we go. I changed it just so y'all can see. So I changed it to y equals 2 times 3 to the x power. That way, because I was going to have to zoom out for y'all to see the asymptote. All right, so this asymptote, do y'all see how it looks like it's touching the x-axis? It actually never is. So if you look at the table, do you see how it's in scientific? Oh, I'm in scientific notation mode. If you're in scientific notation mode, you need to get out of it. Okay, there we go. Do you see how on the x's, when I'm getting closer to 0, look at this. Is it ever actually zeroing out and touching that axis? It's just getting closer and closer and closer. And then it starts writing them in scientific notation because the number is so small, but it's never going to touch the x-axis at 0. So you can see it looks like it's touching the x-axis, but it actually is never touching it. Again, if you look at the table, when I'm at -8, I'm still not at 0. Just the number's so tiny and close to 0 that they had to put it in scientific notation. And you can see it doesn't matter how far down I go, the number's just getting tinier and tinier, like 0.000001. It's never going to touch the x-axis though. That is called an asymptote. It is a line that it's approaching, but it will never touch. Okay? And this asymptote right here is the x-axis, which is y equals 0. Okay? So that's what the asymptote is. So you're going to hear me say those words. All right, so moving on. Let's go over what we just learned. The equation for an exponential function is y equals a times b to the x power, where the first number is the starting amount. The number in parentheses is the growth factor. To find the growth factor, you do 1 plus the percent, but after it's changed to a decimal. To write an equation, just use stat and option 0. So look at the first one. It wants you to take this table and write a function rule. So what are we going to use? Stat. So everybody go to stat, edit. If you have anything put in, make sure you delete it. And then you're going to put the x's in L1. So -2, enter, -1, 0, 1, and 2. And then you're going to go put in your y's. Remember, you can use alpha y equals, so 2/9. And then hit enter, and 2/3. And hit enter, and then 2, 6, and 18. Do y'all notice that the y's are growing rapidly? What is being multiplied here? How do you get from 2 to 3? From 2 to 6. Multiply by what? 3. How did you get from 6 to 18? Multiply by 3. So it is growing by 3%. Yes? Everybody agree? So you'll go to Stat, Calc, everybody look, and you're going to want option 0. So you're tabbing down, or if you knew that it was option 0, you could just hit the 0. See how it says exponential? Okay, so choose option 0, hit enter a bunch of times, and that's your equation. Now, the R's are diagnostics. You don't need to look at them. if you have them still turned on, they're just there. You should have already, okay, so I'm going to go back. Look, stat, edit. Did you get your list put in? Once you have your list put in, stat, calc, option 0. You don't have to tab down. You can literally hit the 0 and then hit enter until it gives it to you. Your equation, everybody look at the top. It's telling you how to write it. It's saying y equals a times b to the x power. Then you fill in 2 for A and 3 for B. It's that simple. Okay? So y equals 2 times 3 to the x power. All right, try the next one on your own. So the first thing you're going to do is go to Stat, Edit, delete what's there, and then you're going to put this list in. Are we good with putting the list in? All right, moving on to this one. So I'm going to put in -2, -1, 0, 1, 2. And then 2, 4, 8, 16, and 32. Now that I have my numbers put in, I go to Stat Calc. What option am I going to choose? 0. And then enter until it gives you the answer. And then write your equation. Now remember, the R's are diagnostics. Don't look at them. So my equation is y equals 8 times 2 with an exponent of x. And y'all can see, look what it's growing at. To get from here to here, what is it? Times 2, times 2, times 2, times 2. This is growing exponentially because it's, everybody look, it's growing by multiplying by 2, but look how fast it starts growing. Make sense? So what would the next coordinate be? Instead of 32, it would be 64. And then it would multiply by 2 again, and it just keeps growing. It's like a rapid growth, these exponential equations. Do we need to do another one, or are we okay? Okay, so just remember, if you have to put in a fraction, you can just divide 2 divided by 9 if you don't want to do the alpha y equals, because y'all's calculator didn't do it like mine. Okay? All right, now let's talk about what if they give us the equation. Everybody ready? If they give you the equation, you're going to use your y equals button, and then you're going to go to second table to fill in the table. Okay, so let's go to our y equals button and type in 2 to the x power. Okay, and then right here above graph in blue says table. So hit second table, and that is going to give you your list of coordinates. Make sure you're not in scientific notation mode, but it will give you some of the answers in scientific notation because they're so small. So tab to -2, and what is the y value? 0.25, write it down. Okay, go to -1. The y value is 0.5. Go to 0. The y value is 1. And then it's 1, 2, and 2, 4. Question. What were they multiplying by to get the next number? 2. Is that the growth factor? Yes. Now, we have to come up with a domain and a range. So let's talk about it. The domain is the x's, yes? So we're looking at what is the lowest x to the highest x, and the range is the y's. What is the lowest y to the highest y. All right, so let's look. To do this, I'm going to use my graph. So we're looking x to x for domain. Everybody look. Is this going to keep going to the left forever? Yes. Is this going to keep slowly going to the right forever? So what is the domain? If it keeps going forever, we call it all real numbers or infinite answers. So all real numbers. Now let's look at the y-axis. Is it ever going to come down here? No, it has an asymptote. Remember the word? It is approaching this line right here where y equals 0, but it is never crossing over. So that's as low as it's going to go. And then is it going to keep going up forever? So to write my range, it's y is, since it's going up, it's y is greater than. Is it ever going to touch 0? No, so it's greater than 0. And guys, almost all exponential functions have the same domain and range. Okay? All right, try this one. Do y'all know what 0.1 repeating is? What is 0.1? As a fraction, what is 0.1 repeating? Nope. It's a 9. I think you can go, just so y'all know, I think you can go to your home screen and like type in a bunch and then hit math, fraction, enter, and it'll tell you. It's a 9. Just so y'all see. All right, what is 0.3 repeating? A third. And then 0, 1, 1, 3, and 2, 9. Question, what is it being multiplied by every single time? 3. Very good. All right, write the domain and range. Go to your graph to look at it. All right, here's my graph. The domain is the lowest x to the highest x. Is it going to keep going to the left forever? Yes. Is it going to keep going to the right forever? So my domain is all real numbers. My range, does it ever go down here? No. So my range is going up. So my range is y is greater than 0. Will it ever touch the 0? No, it's called an asymptote. It's approaching but never touching. Are we good? All right. Turn to the next one. We're going to skip these two because they're the same thing. Everybody, y'all are good with using your y equals button, yes? All right. Now what we're going to learn how to do is we're going to learn how to graph multiple on the same graph, and we're going to learn how to compare them. Everybody ready? All right. The first one they want you to do is this one. Now, we already did this one on the front page, right? Okay, so it was 0.25, 0.5, 1, 2, and 4. Now, look at the next function. What do they have in common? What do they both have in common? The 2 to the x power. So what does this one have different? Nope, this one. The starting amount is 3, where this one's starting amount would be 1, because 1 times 2 is 2. Make sense? So what they're wanting us to compare is if you take the same thing, but you start with 3, what is it going to look like? So go put this in. So let's go to y equals. I'm going to put in 3 times 2 to the x power. And then go to your table. So second table, fill it out. When x is -2, y is 0.75. When x is -1, it's 1.5. When x is 0, it's 3. And then 6, and then 12. Question. Is it still growing by a growth factor of 2? Everybody look. 3 times 2 is 6. 6 times 2 is 12. Is this one growing by a growth factor of 2? The only difference was the starting amount. Yes? All right, now look at this one. What does it have in common? The 2 to the x power. But its starting amount was -3. So let's go put that in. Okay, what did y'all notice? The values are the exact same as this one, except with negatives. Did it still have a growth factor of 2? Yes, now we're going to graph them. You're going to see that I'm going to do it in 3 different colors. If you don't want to, you don't have to. But we are going to graph all 3. So I'm going to start with this one. When x is -2, y is 0.25. When x is -1, y is 0.5. We're graphing. Everybody's graphing. If you want to put some more, you can, because it's growing by 2. What would, when x is 3, y would be 8, right? If you want another one. And the way this would look is it has an asymptote where it's hugging this line, but is it ever going to touch it? No. So here's the first one. This one is y equals, I'm like, can't get it together. Y equals 2 to the x power. Now I'm going to go do the next one. When x is -2, y is 0.75. When x is -1, it's 1.5. And then go graph the other one. So my purple graph is my original graph, okay? We are going to compare my pink graph to my purple graph. So we need to figure out what happened. So when I went from y equals 2 to the x power to y equals 3 times 2 to the x power, By adding in this 3, it changed it a little bit. Do y'all agree? What did it do to it? So everybody look. Do you see my purple one compared to my pink one? It's like they took it and they pulled it up a little bit, yes? That is called a vertical stretch. Vertical means up. So they took it and they pulled it up a little bit. So this had a vertical stretch. So what you need to understand is if they put a number in the front of it that's greater than 1, it's going to pull it as a vertical stretch. Okay? Now, when we started from our original graph, y equals 2 to the x power, and we added a negative 3 in front of it. So we're still comparing this one to the purple one. What did it do? The first thing it did is stretched it some, right? And then it went down. It's a flip. It flipped it across what axis? Across the x-axis. Did it still vertically stretch it? Yes. So the first thing it did was it vertically stretched it. So it's still a vertical stretch, but the negative also reflected across the x-axis. So it had 2 things it did to it. The 3 caused a vertical stretch. The negative caused the flip. So just so y'all know, if they put a number in front that's greater than 1, it's a vertical stretch. If they put a number in front that has a negative, but the number is still like greater than 1 if you took the negative off. Like if you took that negative off, that's greater than 1. So it's a vertical stretch, and then the negative made it flip. Now let's do one where it's not greater than 1. It's a fraction, okay? So everybody flip to the back. This is our last one. Y equals 2 to the x power. Can I just write this one down? We've already done it 3 times. It's 0.25, 0.5, 1, 2, 4. Okay. When I fill this one in, I go to y equals. I type in 1/2 times 2 to the x power. I go to my table and I fill it in. Okay, now I want you to go graph it. If you want to graph 3, 8 for that first one, you can, because that's what it would be at. And this is the first one, y equals 2 to the x power. Okay, then graph this one. Did y'all notice it was kind of like right underneath it? If you want to wait to graph the third one, you can. We can go ahead and compare these two. So just graph the first two, and then we'll compare them. All right, so when I'm comparing y equals 2 to the x power to y equals 1/2 times 2 to the x power, what do y'all think happened when they put that 1/2 in the front? Instead of vertically stretching it, it vertically shrunk it. It's a vertical shrink. Yes? All right, so this is a vertical, we call it compression. A vertical shrink, or you can call it a compression. Now go graph the last one. What happened? Did it vertically shrink it from the original? Yes. What else did it do? It reflected it across the x-axis. So it was a vertical shrink or compression. And it was a reflection across the x-axis. Okay, let's talk about what we just learned. When you take an equation and you put a big number in front, it vertically stretches it. Yes? If you put a big number in front that has a negative, it vertically stretches it and then reflects it across the x-axis. If you put a number in front that's a fraction of 1, like between 0 and 1, it vertically shrinks. What's the other word? Compresses. And then if it has a negative, it flips it. All right, let me get you. All right, on 1 and 2, it says write a rule. Simply use stat. Put it in and then do option 0. Remember to put in the fractions. If you have a regular calculator from the library, just use the division. Okay? If you have my calculator, you can use alpha y equals. On 3 through 11, it wants you to graph the function, so you're just going to use y equals, and then second graph, or second table, and then it wants you to identify the domain and the range. So there will be 3 answers per question. Guys, the domain and range will almost always be all real numbers for domain. If it's above, it's going to be y is greater than 0. If it's below, it's going to be y is less than 0. Okay? No or equal to, because it'll never touch it. Flip to the back. At the top, you're going to graph the function, but I also want you to graph the original function, which is y equals 6 to the x power. Then it wants you to compare it. Guys, you should be able to look at it, and you should be able to say the comparison. So look, this is y equals 6 to the x power. What did they add right here? Since it's a big number, it's going to be a vertical stretch. That's it. Okay? This one, did they add a number or just a negative? So it's going to be a, call it the academic term, reflection across the x-axis. This, they added a number. Is it greater than 1 or between 0 and 1? So it's a vertical shrink. You'll see what I'm saying? But I want you to graph this and this on each one. And y'all don't have to do the word problems.